Welcome to Safety Chats. Host Jason Stark, Director of Safety at Baldwin Safety and Compliance, shares decades of aviation experience and a passion for safety. Let's get started with this week's Safety Chat.
Hello, everybody. Welcome to the Baldwin Safety Chat podcast. It's the podcast where you never know what's going to come out of my mouth. I'm just kidding. We talk about everything that's safety management, safety related, system safety, all the good stuff that hopefully help us do our jobs just a little bit better or become a little bit more informed. Today's podcast, we're going back to systems. And I don't know, I think I like systems. They're cool because system behavior is so fascinating. I go back to the days when I was a practicing meteorologist. I do have a BS in meteorology. That's so fun to say. I'm sorry, I can't resist it, but I do have a BS in meteorology. Meteorology actually is a science, and we take a lot of the same classes that engineers do, things like fluid dynamics and whatnot. But one of the things in my meteorology days is what they call the spaghetti plot. And what they would do is they would model a hurricane, right? They would model the hurricane, and a hurricane is a complex system. And they would introduce little perturbations, like they would change the salinity, I can't even say it, the saltiness, the salination or salinity, however you say it, but the saltiness of the water, or they would change the sea surface temperature, or they would change the upper level winds. They would introduce some little perturbation. And what this would do is they would see how it would affect the track of the hurricane. And that's why they call it a spaghetti plot, because they would do this hundreds of times. And what they would see is they'd have 100 of these tracks, and they would take the median of those tracks to predict the area that the hurricane was going to hit. What the fascinating thing is, if you change one little variable in the system, it could have such a profound impact on the outcome of the overall system. So systems to me are actually pretty neat and not so different than hurricanes. As being a system is we work in systems, right? So our organization is a system. We can actually argue that it's a system of systems. We have our flight systems and maintenance systems, and then our organization itself is a system of systems. So in the whole National Airspace System, the NAS, we have a bunch of systems operating in that system. And we interact with all these different systems in this bigger system, that is the NAS, or the National Airspace System, which is, man, it just like totally boggles your mind. I came across an equation. You're talking about if you had just 10 systems you interacted with, you could possibly have, it's like over 1,000 different combinations of what outcomes could be. But anyway, we're not going in there. But what I'd like to do is I read this book, and it's old. It's an old book. And I don't know what that says about me, because actually it's published when I was 6. But it's called Systemantics. And it's a tongue-in-cheek book about systems. And they come up with these, and I'm doing air quotes right now, these laws of systems. But they're very apropos, I'm going to say a big word there, but they're very appropriate to what we do in safety management, especially when it comes to failures in the system, and failures in terms of incidents, accidents, near misses, but where the system fails. And we got to look at that. I think as safety managers, as we go forward in the future, as we progress, I think we need to become systems thinkers. And I don't say that to scare you. I say that to encourage you that if we start thinking in terms of systems rather than the Cartesian model, which is very linear from Descartes, I think we can see that we can be a more effective safety manager. And what do I mean by that? Okay, in this book, there are, and I'm looking at the pages here, but there are 32 different axioms of systems. And right now I'm looking at 23 and 24. And believe me, this book is fodder for many podcasts in terms of systems. I could probably do a whole season on this book. It's the Kantian hypothesis, the Newtonian law of systems inertia. There's so many good things. Oh, I love this book. I encourage you to read it. It is called Systemantics by John Gall. It was written in 1977, which gives away my age, but it's still very appropriate and still very relevant. I'm going to go to points 23 and 24. 23 says a complex system, a socio-technical system that we work in. It's human beings and technology working interdependently to achieve the goal of the system. A complex system, which a socio-technical system is, can fail in an infinite number of ways. Let that sink in. there are an infinite number of ways in which your system can fail. And chances are it's already running in a fail-safe mode, and actually is axiom number 22. I had to look really quick, but we're not going there. We're focusing on 23 and 24. But a system can fail in an infinite number of ways. And 24 is the mode of failure of a complex system cannot ordinarily be predicted from its structure. So what it's saying is that your system, your organization, your flight operation system can fail in a countless number of ways. And the nicer way of saying that is, if it can go wrong, it will. That's what we see. If the system can fail in an infinite number of ways, and the mode of failure or how it's going to fail cannot be predicted from its structure. So what it's saying, how you operate, how the system is structured, it is not possible, according to Mr. Gall, to determine how the system can fail. And this kind of parlays into, if some of you purists remember maybe how old am I? 20 years ago, that ICAO had 3 methods of hazard identification. They had reactive, proactive, and predictive. And what was happening is people were saying, with the data, I can extrapolate, which you should never do with a regression, by the way, but I can extrapolate when and where my next accident will be. And ICAO said, no, that's not the case. So they removed the predictive method. And so now there's this reactive and proactive. And that's just a side note way of identifying hazards, because we don't know, we can't, it's not linear. But that goes back to the mode of failure of a complex system cannot ordinarily be predicted from its structure. So what it's saying is that your operations that are in place, the structure that is in place, the things that are happening, it is impossible to predict where, based on the structure, it is impossible to predict where the system will fail. And that, to some of us, may be very disconcerting. Isn't that why we're measuring control effectiveness? Isn't that why we're measuring operational parameters? And yes, Todd Conklin, who I admire very much, would say we're looking for that signal where the system may fail. We're looking for that signal, but it may not be where we expect. And that's what I think this axiom is saying, is that based on the structure, we may say, okay, the system is going to fail here. So for example, we may have I'm going to pick one just out of the hat. So I go to maintenance and say, okay, we don't have a tool control program. So we're going to say, okay, the system will fail by a tool being in the intake, or being in the aft compartment, or a rag being in the aft compartment, getting bound up in the cables, or a tool when they start the engine, blah, blah, blah. What this axiom is saying is, no, we can't say that. We can't, because of the structure, because of how our system is structured, we cannot predict where it will fail. The fact that we don't have a tool control program can manifest in an infinite number of ways, and we don't really know. And when we look at hazard identification and we look at audits, for example, we don't have a tool control program, and then there's some proponents that want to risk assess those questions, and we don't really know. We don't know for sure how the fact that we're exposed to that hazard, how it's going to manifest. It can manifest in a number of different ways. And so it's because of the system. So it's really hard to predict how the system will fail. Let's take this back to applying to our jobs, and especially when it comes to accident investigation. And I think we are all past the point that if an accident happens because a pilot made an inappropriate input, I think we're past the fact that we can knee-jerk that to pilot error. Yes, the pilot may have made an error, but we cannot say that's causal, because we don't know how that failure came about. We can't just say pilot error. That could actually be the symptom. That could be the symptom. We don't know what the problem is. Why did the pilot make the error? Do we have poor SOPs? Do we have poor management? Do we have poor training? We don't know. The fact that we can't predict how systems can fail, and the fact that the number 23, a complex system can fail in an infinite number of ways, we don't know. We don't know right away what caused it. And I go back to this example that I used. My family, specifically my sister, works for Airlines, and so I get a lot of stories from Airlines. And my mom worked for Airlines too, so I'm an airline brat. So do you remember, some of us that are older, do you remember when we could check bags for free, right? We could check bags for free, and we could put all kinds of crap down in the underbelly of the aircraft. But when was that? It was after 2011, I believe, that we started charging for check bags because airlines needed a new revenue stream. So we started charging for check bags. That action manifested in many different ways in the system that how could you even predict it? Now we can Monday morning quarterback and say, oh yeah, that makes sense. But okay, now think about this. So when we started charging for check bags, at least for this one airline, we had an increase in the number of on-the-job injuries, especially by flight attendants. And this is the story I tell if you ever go to a class, but you have people shoving 50 pounds of ham in a 20-pound sack so that it can fit on the airplane, and they half-heartedly, try to keep this G-rated, they half-heartedly put it in the baggage compartment. It obviously doesn't fit. The door obviously won't close in the overhead baggage compartment. The flight attendant is now required to take it out or pick it back up, and it's heavy. They lift improperly and they ended up getting hurt. They end up getting a back injury or whatever it may be, or a shoulder injury. So that was one symptom. The other symptom was that gate delays started increasing exponentially because these flight attendants were wrestling with 50 pounds of ham packed in a 20-pound bag into the overhead compartments because people are just like, I'm just going to stick it there, and they want to find a seat or get in their seat. They don't want to mess with it. They're like, oh, the flight attendants will do it. And the overhead baggage compartments at that time were not meant for 50 pounds of ham in a 20-pound bag. And so they were starting to get structural cracks in those. So these were manifestations of a simple thing of charging for checked baggage. How would they even known that it would fail that way? So what I'm saying is that when we have an event, it's really tempting. It is really delicious to point to one thing. That's what we want to do as humans. We want to say, this is the reason, we got a handle on it, have confidence in us. But we have to resist that. We have to look at all the factors surrounding the failures. Now, if you are a Baldwin client, I got good news for you. If you are a Baldwin client, there is a tool in your safety report. It is called the Ishikawa diagram or the fishbone. It's under causal or root causal analysis. You know how I feel about root causes, but causal analysis. So you start with a problem. Pilot had an altitude deviation. And it breaks it down. And then on the fishbone side, if you will, has like training, leadership or management, equipment, processes, procedures. And what it does is it forces you to put narratives in each one of those boxes to look laterally across each of the factors. So we can do the 5 whys. Why did the altitude excursion happen? Because the altitude alert selector was set at the wrong altitude. Okay, why was the altitude alert at the wrong altitude? Because the pilot selecting it was busy also programming the FMS. Why was the pilot also programming the FMS? Because he or she thought it was important to get the new fix in from ATC and also putting in the new altitude assignment. And so when we do the 5 whys, it looks at, okay, it's very linear. And a lot of times it gets back to, okay, the pilot made a mistake, set 33,500 in the altitude selector instead of 330 because their head was down, they weren't paying attention. And we could stop there, and then we could say the remedial action is retrain the pilot on setting the altitude selector, and that is so asinine. But that's just the example I came up with. But what could be happening is that there could be something laterally that, okay, why did the pilot select the altitude selector? Because our SOP says upon an altitude assignment, the co-pilot will immediately put it in the altitude select and doesn't mention anything about reprogramming the FMS. While the pilot now has a conflict because they have to make a quick course change because of a storm or traffic or whatever it may be. So it could be a bad procedure. It could be a bad SOP. And that's the problem that we could have. So we need to start looking laterally. So when we look at the 5 whys longitudinally, we also want to look at 5 whys laterally. And that's where we start looking into systems. Now, that is very cursory on the surface. Because when we start looking and start thinking in systems terms, we want to understand how the different systems interact with each other at the interface. And we also want to understand the influence of each system on each other. So what we have here is we have the management or leadership system having an influence on the flight operations system, which then is being influenced by the ATC system, and there's an influence there. And you see how this can get just way out of control to where you're pulling your hair out. But that's what we do, and that's what we need to do. So I think the call to action here, or the encouragement, I should say here, is let's resist the temptation the deliciousness, if you will, of the linear thinking, of the if A, then B, then C, then D, and that's the outcome. Let's start looking laterally. Let's start looking at how the system may have induced this error because of lateral conditions. And like I said, in the Baldwin system, or even if you're not in the Baldwin system, you can probably pick up a good Ishikawa diagram somewhere. The Ishikawa diagram is actually pretty good because what it does, it's not really truly a systems tool, but what it does is it enforces you to look at other areas and start looking at all the factors that could have contributed, that could have added to the outcome. It doesn't just say pilot did X, which led to Y, which led to Z. It says you had the pilot, that's one of them. Then you have human factors. We could talk about distraction and fatigue. And why were they fatigued? Because we have the short show policy and they were forced to sleep on the couch in the FBO. And you can start thinking of all these things and start really finding failures in the system. And that's what it's about. Because going back to John Gall's book, a complex system can fail in an infinite number of ways, and the mode of failure cannot ordinarily be predicted from its structure. That's the key. And we don't know. So we can't say, and even going backwards, we can't say that this is going to happen or this happened because of X using linear methods. We have to look at the system. And I'm going to say this very carefully. The kind of good thing about the NPRM that came out for 135 operations to have an SMS, or it's going to be a change to Part 5, is this idea of interface management. That the way the FAA describes it is just a really small tease into the bigger picture of systems thinking. And I think if we can become systems thinkers, if we can look at the system as a whole, if we can take this holistic approach rather than the Cartesian, the linear approach, we can start opening our eyes and opening our mind to many different possibilities that could contribute to the end result. So there's so much more on this. I know we're probably like at 20 minutes now, and we try to keep these things short so you guys don't completely space out. But I just want this to be a tickler, and I really hope this is of use to you. Like I said, I may be coming back to this book to do other podcasts. One of the things here that I would love to talk about is, let's see if I can find it. It's called The Fundamental Law of Administrative Workings, or FLAW. That's clever. Like I said, this book is tongue-in-cheek. But it says that things are what they are reported to be. The real world is whatever is reported to the system. Now think about that. Whatever is reported to the system is what's going to become perceived as real to the people in the system. That alone, my friends, is probably worth 2 podcasts. That is deep. And it talks about our perceptions and how we perceive safety in the organization. But I'll leave it there. Thank you so much for what you all do. I encourage you, let's all try to be system thinkers. Let's make that a summer challenge. Let's pick up a book on system thinking. I don't even want to say his name. Burton Alflee. It's a hard name to say. He's the one that came up with the idea of system thinking, but Peter Senge is another one that's big and so is Donica Meadows. So they all have books on systems thinking. And when we start thinking about in systems way, I think we start understanding the world better. But more specifically, we start understanding our workspace better and can understanding where the system can fail. And so if we think linearly, why is that a hard word to say too? If we start thinking in a linear fashion, I'll go there, then we're going to miss the really rich material. But thank you for taking this time to listen to the podcast. Thank you for what you do. And I hope we meet again the next podcast, wherever you listen to this. If you like it, let us know. If you don't like it, also let us know. Or just drop us a line and tell us what we can do better, because we truly want to serve you. But until the next time, be safe.
This podcast is brought to you by Baldwin Safety and Compliance, the leader in safety management for the transportation industry. Since 2004, Baldwin has been providing state-of-the-art solutions and 24/7 support to the aviation and transportation industries. Baldwin's clients include all sizes and types of transportation operators. Baldwin provides safety and related business services to commercial and non-commercial transportation operators, medical transporters, FBOs, MROs, airports, flight schools, UAS operators, firefighters, OEMs, ground transport operators, and others. Visit BaldwinSMS.com to discover how Baldwin can enhance your organization's safety program.